Cool. Yeah, thanks for the intro, Kyle. Really appreciate it. Like Kyle mentioned, my name is Brad Crumey, and I am a solution architect at Red Hat. What that means is I go out and I talk about technology with a bunch of enterprise customers and try to convince them to buy Red Hat stuff. I'm not here on behalf of Red Hat today, though. I'm actually here on behalf of automation and the good things that we can do with it. So I'm going to share a little bit about kind of my philosophy around automation projects, specifically about how we organize our automation code. The tool of choice that I'm going to be showing today is Ansible, of course, Red Hat product. Can you blame me, right? But you can actually apply this using any tool you want, right? So you don't have to use Ansible for this if you don't want to. The method actually works for everyone. Let me start with a little bit about myself. First and foremost, I'm a native Ohioan. I was born and raised in Cincinnati. I will probably live in Cincinnati for the rest of my life, which consequently is a very common thing to hear about Cincinnatians. I have over 2 decades in tech. So prior to starting at Red Hat, I ran production environments. I actually did the work. I was a Linux sysadmin for a long, long time. And I consider myself a super nerd, although Ben, who was just up here before me, he like beats me in that category for sure. I don't get into C or Rust or any of those other languages. I do a little bit with Python, but not quite to the level he is. So excellent, right? I enjoy whiskey, so if you also enjoy whiskey, we can talk about it afterwards, especially like bourbon, but I don't discriminate. I'll drink scotch as well. I am the father to 2 humans, both of whom are adults now, and I'm also the slave to 2 felines, which is important for some of the conversation we're going to have today. You'll see why here in just a little bit, right? So I like to start all of my talks with kind of illustrating an example of the concept I'm trying to kind of teach you about, right? And this talk is about patterns, and specifically embracing patterns in the designs of our application and IT service architectures. To illustrate that, I want to start with a definition and then go through a few steps to kind of show a pattern that doesn't have anything to do with technology, and then apply the same method to technology as well, right? So here's a definition of pattern. If you look the word pattern up in the dictionary, you'll find probably like 5 or 6 different definitions. This is one, specifically a natural or chance arrangement of component parts, traits, or elements. And since we're talking about natural or chance arrangement, I thought it was appropriate to talk about something maybe from the animal kingdom. So let's do that. What I've done is I have compiled 3 relatively simple traits that you'll find in animals throughout the animal kingdom, right? You guys get to guess. So this is interactive. You guys get to guess what animal I thought of when I chose this trait, right? So first one, slender muscular body. What do you guys think? You guys are getting really, really far ahead. Actually, I thought about snakes, right? In this case, it's a Burmese python. Really slender, very, very muscular. If you've ever dealt with a snake, especially a python, they are very strong. Okay, next. Strong, flexible forelimbs. What do you guys think this one? Monkeys. That's actually a good idea, right? So somebody said monkeys. In this case, how about strong, flexible 8 limbs? It's an octopus, right? If you ever dealt with an octopus or seen what they can do, they're very strong as well, right? Last one. Sharp curved claws. What do you guys think? Eagle. Really, really close. I chose a hawk, right? And you guys are kind of getting a little bit ahead of me, I think, because somebody said cat earlier. But let's put all of these together, right, and see what we get, right? So if we take our slender muscular body, right, and our strong flexible forelimbs, and our sharp curved claws, what do you think we get? That is a cat. Right? And in this case, we have what looks like a relatively typical house cat, right? So we didn't really describe a house cat, though, did we? We just described any cat. But what do we do if we want to describe a house cat or a different kind of cat? Well, we have to add detail, right? So let's add some detail now, right? First detail, the cat needs to weigh 300 pounds. That's a big cat, right? Yeah? Here's one that a lot of people don't really think about when they think about cats. its eyes need to have round pupils instead of split. We're very used to seeing cats that have split pupils, right? Well, what cats have round pupils? Well, just so happens that it's all the big ones. So we added a couple of criteria, but we really didn't narrow things down other than, hey, it's a big cat, right? So this last one, I think, should narrow it down to a specific cat that we're looking for pretty quickly. It needs to have orange fur with black stripes. Tiger, right? Yeah, it's a tiger. But for the purposes of what I'm talking about today, the fact that it's a tiger isn't the important part. The fact that it's a cat is the important part. Because when we talk about automation and we talk about patterns, we want to try to dissect our patterns and use the most common denominators in order to enable the services we're enabling for our customers, right? All right, now that we've done this, let's do the same exercise, but we'll do it with tech, right? Real quick before that, though, I want to make sure that we kind of cover a different definition or a modification of the definition of a pattern. Well, in nature, things are natural or chance, right? The patterns that we see, they happen, I won't say arbitrarily because it's probably not the right word, but they happen naturally, right? In technology, things don't happen naturally. Things happen the way we want them to happen. We decide what the arrangement of component parts, traits, and elements are. So I just took that part out from the beginning of the definition, right? It's the same thing, just a couple less words. So let's apply that same method to IT service and its parts. First one, web-based front end, right? What might we have that is a web-based front end? Anything. Ben before us was talking about HTTP libraries, right? So he was talking about a lot of web-based front ends. In my case, I chose Node, right? Because that's a place where you can put, web-based code that will provide a front end, right? Next, API-based backend. What do we choose here? Any choices? Anybody have a backend of choice that they like? No? Okay. I choose Wildfly. All right, if you're not familiar with Wildfly, it's the upstream project for JBoss. Right? So you can get JBoss for free. And then extensible relational database. MySQL, good choice. I chose Postgres. Right? So let's continue. Right? This kind of lays it out for us already, just because I've chosen the components. But let's do the same thing. Let's add some detail. Right? Our web-based front end is our presentation tier, right? Our API-based backend is our logic tier. They serve different purposes, right? And then our database is our data tier, right? Overall, though, what is this? What am I describing here? Web application, I'm hearing. Multi-tier app, 3-tier app, whatever you want to call it. That's what I'm describing. The individual components could be whatever you want them to be. At the end of the day, though, it's still a multi-tier application, so we're still following that exact same pattern, right? Let's add some details. Do that again. Presentation tier is HTML. I don't know who's going to use HTML in a presentation tier anymore, maybe a little bit, but mostly we're using other languages at this point. The logic tier is .NET. Ew. Right? Right? And then our data tier is SQL Server. Double ew. Right? So what are we describing here? Right? Microsoft Web Application, exactly. But the point is, exactly like with the cat example, it's a multi-tier app. Right? Now, I don't often talk to customers that do things with Windows. I'm usually talking to their Linux teams or their operations teams who are working on Kubernetes or in the clouds. But this comes up every once in a while, right? The important part, like I mentioned, it's still a multi-tier app. Right. So how do we view our IT services and applications, right? So let's make a comparison between the way things happen in nature or biology, like the animal example, and how we might do things with technology. With biology, we have biological taxonomy. Who took biology in high school and remembers this taxonomy, right? Pretty much everybody, right? Now, I was talking to a gentleman yesterday in the hall who said that they do things completely differently now. They use the genome to decide this at this point, right? Which I didn't know, so my slide is already out of date. But, but the point here is we have layers, many layers that as you descend down this ladder, each layer becomes more and more specific or more and more unique, right? We group organisms based on the genome at this point, I guess, but on shared characteristics, right? So those organisms that have the shared characteristics toward the top are going to have more. The more specific we get, they're going to have less and less and less shared characteristics, right? And the lowest step on the ladder in this case is an individual species, right? So if we apply that same taxonomy, but instead of biology, we do it with technology, right? First thing is, it's a whole lot less complex. We have way fewer layers, right? You can group your components based on their function, what they do, right? And then you can subdivide those functions into different types, right? And I'll give you guys good examples of this here in a little bit, right? And then the lowest step on the ladder is a specific application stack. Not just an application, but the entire stack, the entire landscape of that application, right? Same applies here, though, with the biological taxonomy and the technological taxonomy. The further down the ladder you go, the more specific you get until you're at a unique application or landscape, right? So let's go into more details about the technological taxonomy, right? A function, right? So we had kingdom, phylum, class, et cetera, in the biology side. On the technology side, we start with a function at the very top. You could think of a function as the high-level purpose or role of a layer or a component of your application stack. So think web server would be a function. Database server could be a function. Server, just operating system, Linux operating system could be a function, right? So these are the high-level components. If we go down the taxonomy and get a little bit more specific, we go into a type. Let me get past this little animation real quick. And the type is going to describe the composition or variety of that particular function, right? So instead of just web server, we have Apache web server, or we have IIS web server. Instead of database server or database instance, we have Postgres database, or MySQL database, or DB2 database, right? And then we go one more level down, and we have what I call a landscape. Now, this is often referred to in Ansible land as the site configuration. So you can call it that if you like. But the landscape is really the specific implementation of a large set, or a set, it doesn't have to be large, of functions and the respective types that you've chosen for your particular app. So you can see, as we're building these things out, you can see the patterns emerge with everything that we build, right? Because not everything uses the same type across the organizations that we're trying to enable. These landscapes are the snowflakes, right? These are the individual things that are going to be very, very unique in our environment. Okay? At this point, you're probably thinking, okay, we were going to talk about automation, right? And we haven't talked about automation at all. So yeah, let's actually get into the automation part, and I'll show you how the pattern here applies with Ansible, right? So let's kind of translate some of those different components or different ideas with what we do in the world of Ansible. So functions, as the building blocks of our application stacks or the building blocks of our landscapes, they get converted, well, not converted, but they get represented in Ansible as an Ansible collection. So quick show of hands in the room. Anybody familiar with Ansible, use it on a daily basis? Oh, excellent. So you guys are probably familiar with kind of the history of Ansible a little bit. Up until 4 or 5 years ago, everything that you could do, that you could automate with Ansible was included in the main Ansible package, right? 2019 came along, and we decided at Red Hat, of course, because it's our project, we decided we're going to split that stuff out. The main reason for that is so we could actually do more rapid releases of the Ansible core engine. And we weren't beholden to all of the community or third parties to release Ansible because we were waiting on content from them, right? So we separated out what we call content collections and made it more modular, which has actually accelerated the release cycle for the Ansible core engine significantly. And it's also made the community around automation content from our partners much, much better as well, right? But a collection you could think of kind of as just a way to group automation capabilities that are alike for a particular use case. So think Cisco iOS, for example. There's going to be a collection for Cisco iOS. Or Nginx has a collection for all the Nginx stack, right? Types, since we're getting more specific here, our types gets translated into Ansible land as an Ansible role. So for those of you who said you're familiar with Ansible, you've probably seen Ansible roles before, right? It's one of the common things that we try to use as much as possible. There's a huge community around it on Ansible Galaxy, where you can consume roles. You can actually consume collections out there as well. Thousands of them that are available out there. So in a lot of cases, you might not have to do this yourself. But those types, like I mentioned before, are the individual implementations of a particular function. So instead of just being web frontend or web server, we're going to have web server and then Apache web server or IIS web server, right? And then landscapes, going down the taxonomy a little bit further, are combinations of those functional types that we've chosen for our particular IT service or application, right? And those in the Ansible world are represented as Ansible plays and playbooks. You could write it all into one big playbook if you wanted to. You could also write it into multiple playbooks, one for each function, and then combine those playbooks into a playbook of playbooks using includes. Right? So what does this look like? Let's give you an example of what an Ansible collection looks like. Right? So this, I used a tool that just was released a little while ago called Ansible Creator. If you're not familiar with Ansible Creator, it is available for anyone who wants to create an Ansible project, either for a collection or for a playbook project. It'll initialize the entire directory structure for you, put things in the right places, so you don't have to worry about creating it all yourself. It'll do other things like add a dev file if you're using dev spaces. It'll give you a dev container file if you're trying to code in dev containers in Visual Studio Code as well, and it'll automatically configure that for you, which is awesome. So let's go through this collection project or repository. You guys are using source control for your Ansible, right? Yeah, good, okay. And talk about what this is. So at the very, very top level of the directory structure here, it's called front end. So this is the name of the collection, and it matches our function. Right? So we have a front end collection. It's going to configure our front ends or our possible front ends. Right? Going down the stack, that collection might also include Ansible plugins or modules. So for those of you who already use Ansible today, the collections that you pull in from Ansible Galaxy, you're probably using them in order to get to the modules that have been created to do automation work. Right? You're probably still going to do that. But that's not the only purpose of an Ansible collection. The other purpose for an Ansible collection is exactly this, is creating a place to put roles that have a similar kind of use case so you can put them all together and call them as one namespace. Right? For use cases that don't have modules or plugins available in the Ansible community, you can create your own as well. They're written usually in Python, but if you're doing things on Windows as well, PowerShell. Right? Okay. And the collection is also going to include the Ansible roles that we talked about, one for each type of that particular function. So in this case, we have our front-end collection that provides a front-end function, and then we have three types. We have an Apache type, an IIS type, and a Node.js type. Right? So you can start to see how we can kind of collapse these patterns we use into more manageable chunks of automation code and repositories, so it becomes easier to use long-term. Let's do the same thing with the Ansible role structure. Now, I'm not going to go into the individual files inside of the Ansible role itself. I'll explain a little bit. But from a role perspective, you'll notice that we have the top-level directory is front-end roles. And then inside of there, we have a directory for each of the roles that we're going to include in the particular collection or for that function. Apache in this case. And each type, if we're using taxonomy, each type has its own role. Right? So now, we have an Apache role, we have an IIS role, and we have a Node.js role. Right? The role functionality gets modularized. Right? So if you're not familiar with Ansible, the entire purpose of an Ansible role is to create a shareable, standardized way to automate a particular thing. Right? So in this case, we have the example of Apache. This would be a shareable, standardized way to install and configure an Apache HTTPD web server. Right? It's going to have defaults. that are included with it. It's something that's very important when it comes to Ansible roles. You'll set what your default configuration might be and set them as variables in this defaults directory here for Ansible. You could think of the defaults as the same kind of configuration that if you were to use this role in an Ansible playbook, right, without any parameters set, without any kind of variable set, these defaults would take over and be what end up being applied to your configuration. Okay. Something that I tell my customers pretty regularly as well is the separation of your automation function and your configuration is really, really important, or imperative. So you'll notice I gave you examples of a collection, I gave you examples of roles. I didn't give you examples of playbooks quite yet. The reason is we want to keep that separate because our playbooks, our individual configurations, the variables that we set for our landscapes that we want to configure need to remain separate from our functional automation code. Right? Our automation code is what it is. We need to make sure that all of our site-specific data stays separate. All right? So let's give you an example of a playbook project. I mentioned Ansible Creator before. You can create a collection project or you can create a playbook project. This is what a playbook project looks like pretty much out of the box. I've renamed a couple of things just to let you guys see it. Right? So the project name is going to match the landscape you're trying to apply. Right? So this could be, in my case, awesome app. It could be application 123. It could be financial services payment app or something like that. Right? The collection requirements are defined inside of this project. We're not defining the collections or putting the collection repositories or directory structures in this project. We're just referring to them using a requirements file that says, I need to pull this collection in from here. From either Ansible Galaxy, pull it in from Ansible Automation Hub. If you have a tarball of the collection that you've tarred up and said, hey, we're going to go get it from this web server, you can do that. Right? Your inventory is a directory structure. I'll explain why this is important in a little while. But your inventory is going to include your to-be configuration. This is the configuration you want to apply with your Ansible project. Right? And your variables get defined in subdirectories called group_vars and host_vars. We'll go into a little bit more detail about that as well. Okay? Then you're going to have playbooks for each function of the landscape. I mentioned this before. But you'll notice in the example here, I have a front-end playbook, and I have a back-end playbook, and I have a database playbook. One for each of the functions in my three-tier, multi-tier app. Right? And then we also have a consolidated landscape playbook. This is often referred to as site.yaml instead of landscape playbook.yaml, which is a playbook of playbooks. And that can be used to configure the entire stack of the application. Every single server that might be included in an application, or maybe it's a container and you have to configure it. Maybe it's a Kubernetes namespace that you're deploying to, would be considered, would be, be included in one of those function playbooks and then included in the landscape playbook. Okay, so let's talk about organizing the site-specific data a little bit. Okay. The first thing you want to make sure you do, and this is just a good practice, right, is identify your single sources of truth, or just sources of truth, because you might not have a single one, and use them for your Ansible inventory, right? So if you have a CMDB or an ITSM tool that keeps track of your systems, use it, right? There's no reason to reinvent the wheel and write a big old text file out with your Ansible inventory when you can run a Python script and grab everything from your CMDB, right? The data from those multiple sources of truth should not overlap or contradict each other. This should be pretty self-explanatory. If you have conflicting data, you're going to have conflicts with your automation, right? Conflicts when you're building your inventory. And then you should combine your single sources of truth into one inventory using a dynamic inventory plugin. A lot of the collections that are out there from third-party vendors, think ServiceNow or Cisco, they include inventory plugins in order for you to build your inventory dynamically from a source. AWS has one, Google has one, Azure has one. So if you're working in any of those clouds, you can build your inventory based off of what you've got in EC2 already. Right? Next, we want to differentiate between our as-is and to-be information. Right? So when it comes to Ansible, at least, we collect the as-is information mostly in the form of Ansible facts. So it's facts about a system that exist already. They're inherent to that particular server or system that we're automating against. And by default, we collect those when we start an automation, right? You can turn that off if you need to. We could also have an as-is kind of project, if we want, that defines what our desired state is, right? And then when we automate, we can then transfer the automated to-be into the as-is, right? The managed to-be information gets represented as variables in your Ansible inventory, right? So it's a project directory that you have all your playbooks in, and you have your inventory in, and you have your variables in. So it's one place for you to modify your to-be architecture, your to-be configuration. I already mentioned this, but define your Ansible inventory as a structured directory instead of a single file. The main reason for this is because it's easier for you to go look and say, hey, what's the variable that's set for this particular system in my inventory, or for this group of systems in my Ansible inventory. Right? And then restrict the usage of variable types. So this one is really, really important. In Ansible land, there are 22 different layers of variable precedence. If it sounds like a lot, it is. Right? The method that I'm showing you here narrows that down to 3. So you use group variables in your inventory, host variables in your inventory, and then your defaults that are defined in your individual Ansible roles. Right? You want to avoid scoped variables and extra variables. So scoped variables are ones that get applied for a particular scope in Ansible somewhere other than where you want them defined, right? And then extra variables are ones that you pass on the command line when you're running your Ansible playbooks, right? You want to try to avoid running, putting variable data on the command line if you can. You should be able to. So let's take a look at inventory a little bit deeper now as well, right? This is a pretty typical Ansible inventory file. This one is YAML formatted. For those of you familiar with Ansible already, you'll know that the typical format for an Ansible inventory is INI format, right? Essentially, it's just a list of the systems that are in our inventory that we want to automate against. This one's formatted in YAML. It could be in INI. It could be in JSON as well. At the end of the day, when Ansible looks at your inventory, it translates it to JSON anyway. Right? So you'll see in the inventory here, we have a list of hosts. We have, at the very top level, a group called all. And we have the hosts that are included in all. Then we have the children of the all group, which is pretty much any other group in our inventory, which includes web servers, app servers, DB servers. Each of them has their list of hosts as well. Right? Each function, since we're talking about automating a particular application stack, each function in your application stack should have its own inventory group in the inventory. That way you can apply that configuration for that function to that group very easily with a single play. The variables need to be set in your group vars and host vars instead of the inventory file. So you can actually set variables in this inventory file if you want to. But if you start setting variables here, it becomes really, really messy. Right? So putting them in the subdirectories is a way, way better option. Right? It simplifies variable precedence as well. Like I said, instead of 22 different levels of variable precedence, you're down to 3. The other important thing is inventory groups can contain other groups, right? So you can do nested groups of hosts in your inventory. You can do intersections of groups when you target them in Ansible, which is really, really awesome. So you could say something like, I want to automate against all web servers, but I have web servers that exist in 3 different data centers. But I only want to automate against the systems that are in web servers and also data center 1. You can do that. Or you could say, I want to do web servers, but not servers that are in data center 2, for instance. Those are the kind of things you can do in your playbooks when you're targeting your servers to automate against. Okay? And of course, individual hosts, like I said, they can exist in multiple groups as well. And for those of you who are Red Hat customers, if you have the same host in multiple groups in your inventory, it still only counts as 1 license. If you do it right, yes. Yeah. All right. So let's give you examples of inventory variable files, right? So each group is going to have its own group vars definition file, right, where the variables are set for that particular type. You could actually set variables for multiple types in this if you want to, and then you can use conditionals to determine which type you're going to apply to a system, right? So in this case, we have web servers and DB servers that have some variables set for the Apache listen port and also the SSL listen port, right? And then for the database, we have our Postgres listen port. Now these are all defaults, of course. If we wanted to set them to something different, change the value of the variable, right? Relatively straightforward. Okay? The variable names and keys should be meaningful, right? So this is something that's another good practice that came from the Ansible community of practice a long, long time ago. Your variable names and keys should match the role that you're calling. So, or at least have a prefix for the role that they apply to. So in this case, we have Apache HTTP port and Apache HTTPS port. Well, that prefix to those variables matches the Apache role that we're using from our front-end collection. Right? Same thing with Postgres. The PostgreSQL listen port matches, the prefix matches the name of our PostgreSQL role from our database collection that we created. Right? Then, of course, variables that apply to all hosts go in the all.yaml file in your group vars directory. Right? So you can apply something to everything if you want to. In this case, we're setting the application version or app version. Right? That one is one that is not doesn't have a meaningful prefix. Maybe we use it across all of our different roles that we're applying. Right? And then, of course, individual hosts can have their own specific variables in the host_vars directory as well. So if we want to set something more specific for just one system or just one or two systems, when we have a group that includes 100, we can go set that for that individual host in its representative file. We've got some playbook examples as well. So let's go through those. So the functions are going to get contained, like I mentioned before, in their own individual playbooks that call the role for the individual type. So these examples you see on screen would be the entire playbooks. The first one, for front end, we have an entire playbook that'll do the whole thing because we've separated our automation logic from our automation configuration. Right? So that one says we want to configure front-end web servers, and we're going to do it on the web servers hosts. Right? Become means we're going to do privilege escalation and do this as root because why not? And then we're saying, hey, the role bpcrewme.frontend.apache is the one we want to apply to this server. Right? The playbooks can include other roles as necessary for the host. So, for instance, if this is all on Linux architecture or Linux infrastructure, and you use the same distribution across all of your systems, and you've standardized the configuration for your Linux hosts, you could create a collection to do your standardized Linux configuration. It could be called like, my name here .linux as the collection name, and then you have roles for everything that you apply under the covers. Maybe time synchronization. You could have a time sync role. Maybe disk configuration. You have a disk configuration role, right? And then you can just put this in a list in these playbooks and say, hey, we're going to apply our Linux time config and our Linux disk configuration roles, and we're going to do our front-end Apache role. Right? And it can do it all in one go. All right? The functional component playbooks then get aggregated into a single landscape. And this is what the entire landscape playbook would look like using this example. It's just a YAML file that says Ansible built-in import playbook, and then you give it the playbook name. It runs them in order. Right? So this actually probably isn't the right order. We probably want our database first. Right? But we can make things very, very simple if we start using these patterns and applying things using just a couple little rules around our Ansible projects. So how do we scale? Right? Because if we're talking about enterprises or we're talking about commercial use, this is going to have to scale. We're going to have to be able to use this over and over again and be able to have multiple teams consuming the automation, right? Okay? The patterns follow your architecture. This is something that's very, very important. Before I came to Red Hat, I worked in a production environment for over 20 years, right? We had the same patterns of applications that were used over and over and over again. Now, we had like 15 different patterns, but we used the same things over and over again, right? Every once in a while, we would have something else that we needed to add to a particular application stack. The cool thing is, those new architecture elements can become a new function. So for instance, if you have to add a data caching layer with something like Redis, you could create a data caching function or data caching collection that has a Redis role. and then apply that configuration to the appropriate systems that need to have that Redis function applied or that data caching function applied. Right? And this new functions become new Ansible collections, like I mentioned, and then new types become new Ansible roles. Right? So you can just rinse and repeat with these new functional components of your applications and do it over and over and over again. Right? Now, I don't know about you, but when I was working in a production environment, and every customer that I talk to nowadays, they have multiple teams, and each team is kind of siloed into their own particular use cases. Right? Well, the good thing about this is domain experts can remain domain experts. And more importantly, each team can create and maintain their own Ansible collections. Right? So if you have a web infrastructure team, they can create the collections for doing web infrastructure. If you have a networking team, they can do create all the collections for doing networking, and so on and so forth. There's no reason to have one centralized team do all the automation. Now, the uphill battle with this is getting all those teams to adopt Ansible as the tool they want to use. Right? But if you show them how easy it is, usually at least one person on that team is going to say, yeah, I want to do this. Usually, not always. The next thing is something that you can do. Publish, share, and reuse the collections and roles that you create. There's no point in creating this and trying to automate and trying to scale it if all you're going to do at the end of the day is have every team create the same stuff over and over again. Right? So publish your Ansible collections. Create a release as a tarball on GitHub if you want to. If you're using GitHub Enterprise or GitLab or whatever, you can create a release there. Upload it to Ansible Galaxy if you're allowed or if you want to. Right? Ansible Galaxy is the community for exactly this. Share your collections out to everyone else so they can use them too. Right? If you are a Red Hat customer and you have Ansible Automation Platform, we include Private Automation Hub for this. The upstream project for that is called Galaxy NG. So if you want to enable it yourself without paying us, you can go get Galaxy NG and publish all your stuff to a centralized location on your own. Share your Ansible collections. Make automation functions available to everyone else. This is going to require a lot of evangelism from inside of your organization if you're working somewhere. It's going to require somebody who's pushing the idea of let's use Ansible, let's use these Ansible collections, let's not reinvent the wheel, let's standardize the stuff that we're doing and do it over and over again exactly the same way. Right? That'll help to enable standardization through democratization. Because as you convince more and more teams to adopt this method, to adopt using Ansible, or whatever tool you choose, it doesn't have to be Ansible, then everybody can be on the same page. And all of a sudden, you're talking the same language when it comes to enabling your infrastructure or enabling your applications, which is a beautiful thing when everybody's on the same page. It doesn't happen often. And then reuse your Ansible collections as much as possible. Don't reinvent the wheel. Only create a new collection when there's a new function that requires it. And of course, roles when there's a new type inside of that function. This also kind of helps you prioritize some of the things you need to do. So I don't really touch on this, but I'll mention something about it. When you have a function that you use regularly and a role inside of that function that you use regularly, and you all of a sudden have a need for a different type. Let's say you're doing Apache web servers and more Apache web servers and more Apache web servers, and then some team comes along and says, no, you know what, we want to use Nginx. You can just create a new type when you need to, create a new role when you need to, and put it into that collection. Do all the testing of that behind the scenes, and then all of a sudden, creating the playbook to do Nginx becomes really, really easy. And in a lot of cases, you might not even need to create it, because I know Nginx releases a lot of their automation stuff on Galaxy already. Right? And with that, time for Q&A. Any questions?
Are there any questions? Oh.
Yeah.
Excellent talk. Thank you.
Thank you.
So at the end, I was hoping you'd get into more of how do you manage the interdependencies between the collections? How do you install them? How do you maintain them?
Okay.
If I got things like I got to make changes to my playbooks, but now it's in a collection and a role in there, but I'm not, someone else is writing that. How do I change it?
Right.
Do you get submodules? Do you put everything, that sort of thing?
Yeah, so I don't really go that deep into it, but I can talk about some of those things a little bit. The first thing to kind of touch on, how do you manage the dependencies of your collections and those sort of things? Along with that separation of Ansible engine to and the content that was shipped along with it. We introduced a way to kind of manage dependencies in a more, we'll call it cloud native way. And what we did is we introduced what's called an execution environment, right? Two reasons for that. The first one is the prior way of managing all of your dependencies was using Python virtual environments. And if you've ever worked in a Python virtual environment, it's a pain in the butt. And when we're talking about scaling across an enterprise, maintaining a Python virtual environment on one machine is a pain enough. Doing it across 3, 4, 5 machines that are doing all of your Ansible is even worse, right? So what we did is we created this concept called an execution environment, which is a really fancy way, or not really that fancy way, to say a container image that has everything in it, right? So what you will do as probably another project or a sub-project of your collection is you'll create either a subdirectory or have it in a completely different repo, the configuration for your execution environment for that particular function, right? And that execution environment is going to include the collection requirements that it needs. It'll include the Python library requirements it needs. It'll include the version of Ansible core you want to use. It'll include any binary dependencies you have. So if you have a command line utility or something you want to use, maybe you're using Git to pull something down and do things with data. You can install Git inside of there as well and do those things you wanted to do. So you're going to have another project for that execution environment. And then you'll use the Ansible developer toolset, which is available from PyPy, Ansible-dev-tools. It'll install every single Ansible developer tool that you need, except for the Visual Studio Code extension. Then you'll use Ansible Navigator, which is our new kind of CLI text-based user interface for interacting with Ansible. The reason for that is because you can use execution environments right on the command line, right? So Ansible Playbook is still there, it's still under the covers. You can still use it if you want to. The disadvantage is you have to maintain all those dependencies on one system in one Python virtual environment, or manage Python virtual environments instead of execution environments. Yeah.
Any other questions? All right, I didn't see any in Slack, so thank you.
Awesome, thanks guys.